Awesome. Well, I'm Austin Federa. Thanks for having me here today. I am one of the three co-founders of the DoubleZero protocol. I spent the last 4 years at Solana Labs, then the Solana Foundation, worked on product, worked on marketing, ran strategy for the organization, and then left last year to build DoubleZero, which is a project to recreate the internet from the ground up for high-performance distributed systems. What do we mean when we say all these words? For pretty much the entire history of blockchain technology, everything is run over the public internet. And the public internet is a great resource if you're building Bitcoin and there's no other frameworks to build this on. But the public internet is not what traditional finance uses. It's not what traditional finance has used for over 30 years. It's not what large tech companies use. They all instead build global private fiber networks to allow their systems to move beyond the speed that the public internet is capable of. So this is a high-performance global network purpose-built for the needs of blockchain and other types of high-performance systems. So this here, which the contrast has done quite a job on, is a map of the world. And there is an overlay of this, which is the DoubleZero fiber network. What this is a global fiber network run by 11 independent contributors all around the world. Why is it important that this is run by independent contributors? For the same reasons that we want all different blockchains run by multiple independent parties. You don't want any one entity having control over a network. And so if you think about this on the compute side, this is why we put a high price on things like a Nakamoto coefficient. How many independent entities are involved in running the staking infrastructure for a particular blockchain? If it's one or two or three entities, we say that's a fairly centralized chain. If it is 30, 40, 60, 100, we say it's a fairly decentralized chain. The same thing applies to the network layer infrastructure. And so this is the piece that most people don't think about. If you would guess how decentralized is the public internet, I think most people would say it's pretty decentralized. It's the public internet. Well, it turns out there's only about 10 to 14 companies that actually run all of the tier 1 services that the public internet is based on. Don't even get me started on DNS. That's a whole other can of worms. It's even more centralized. So when we think about these things, the actual major choke point for even a system like Ethereum today with 12,000 nodes around the world is the public internet. And we don't think about this as the limiting factor, but if you remember a few months ago, Afghanistan turned off the internet and every single blockchain node running in Afghanistan went offline. Most countries in the world nowadays, unless they are sort of like tier 1 democracies, have government control over the internet and they have the ability to turn it on and off at will. If you're thinking about censorship resistance, you have to think about who actually controls the pipes and the plumbing. You can't just think about who controls the code and the validators. And this is where we take a very different approach to this. We are running on the same types of cable systems, and our contributors are contributing fiber on these cable systems that some of the world's largest businesses and financial systems run on. And so the act of censoring the public internet is a much lower barrier for many of these organizations than censoring NASDAQ, Wall Street, big trading firms, Facebook, Google, Amazon, Meta, all of these different types of organizations. So last year in December, we put out a white paper on how to build a new internet optimized from the ground up. And since then, we've had a lot of success in that process. So the DoubleZero network is comprised of multiple independent contributors on the fiber network, but we have different core teams working on it. So we have the core contributors, which are very similar to like a labs team or a protocol team that are building software and software implementations for the network. And then we have the actual network contributor layer, which are the fiber providers themselves. And then validators, users, RPCs, anyone connecting and operating systems on the network are the main users of the network. So as like a user staking to a protocol, you're not really interacting with DoubleZero. But if you're running validators and RPCs and MEV infrastructures and searchers, you may be choosing to connect your validator infrastructure to DoubleZero. But we're not a bare metal service provider. We're not a hosting provider. We're not actually providing you servers or hardware or adminning these things for you. That's all up to you. What this is a different system that your validator or your RPC services talk out of. You can think of it as there's two network cards in the back of your computer. One goes to the public internet. One goes to the DoubleZero fiber network, which operates at much higher speeds than the public internet allows you to run. So why do we need this, right? Why do we need this is like a major question here. It's cool. We love building cool systems. We all love high performance systems. This is why we need it. This is a graph of the internet, round trip time from LA to Singapore, over a whole bunch of different types of cable systems and systems. So if you look here, this yellow and orange line are two different samples over the public internet. And what this is a plot of is latency. And latency is, if you grew up playing video games online, it's your ping time. It is the time it takes you to talk to a server and the server to talk back to you. What you see here is the public internet, although this is an incredible service that I can even talk to a computer in Singapore from Los Angeles. Like, we can take a moment to appreciate just how incredible the internet is. It's quite inconsistent. So you can see in the morning here, it's varying anywhere between maybe 275 milliseconds and, like, let's call it 350 milliseconds for the time it takes to go back and forth. You see here later on in the day, the public internet actually switched to a different subsea cable. Your data used to be routed over one cable, and now it's getting routed over another cable, and that cable system is slower. Now, why did this happen? There's all sorts of reasons, but at the end of the day, it comes down to cost. The fundamental unit economic of the public internet is how cheaply you can move data from point A to point B. That is awesome if you're watching a YouTube video or posting on a message board. If you are propagating block data or you are trying to get your transaction included by a leader and the blockchain is running 400 millisecond block times or 100 millisecond block times, good luck. All of your transit time is taken up in network latency. This blue line on the bottom here is the DoubleZero. This isn't even our mainnet, this was testnet. And so what you see is throughout the day, it's incredibly consistent performance, sitting at about 225 milliseconds, and there's almost no variation there. That variation is what's called jitter. And jitter is a real killer for high performance systems. So if you are saying to someone, look, it's always gonna be 400 milliseconds to talk to Singapore, and I'm a trader, I can program around that. I can understand that sort of static limit on my system. But variability is incredibly hard to take into account for high performance systems, and that's part of why blockchains built on the public internet, the testnet's always much more performant than mainnet. Why is that? Every single testnet out there can hit numbers in testing environments that the mainnet gets nowhere near close to. Now, mainnet load is different than synthetic testnet loads, but a major portion of this is block propagation and consensus over the public internet. So, as I said, no real technology companies use the public internet. You'd think of many of these names as public internet companies. Oh, Meta, of course, they're a public internet company. Well, they're actually the largest investor in subsea fiber, and they run one of the largest private fiber networks of anyone in the world. And why did they do this? It's not out of the goodness of their heart to make the internet better. Why did they come in and build the entire internet infrastructure for the Philippines over the last few years? It's because they want to sell you more ads. And the best way to sell you ads is if your Instagram reels load really quickly and you just keep scrolling. And so if the foundation of like Web 2 ad tech is not even using the public internet, why are we trying to use it to rebuild the fundamental nature of finance? We're never going to be able to compete with NASDAQ and NYSE and Robinhood and all of these other use cases in traditional finance if we're running over the public internet and they're running on something orders of magnitude faster. Even eBay runs a private fiber network. eBay. Like, what does eBay even do these days? And they still have a private fiber network. So this is what I was talking about before. Least cost routing leads to inefficient routing systems. This is an example, and this is actually a real test that we've run many times, is pinging a server in Seattle from New York. And this is the path the data takes. This is not an accident. This is not a bug in the public internet. This is a feature. This is how you can pay in the United States $40 a month for a 1 gigabit internet connection. That's an incredible value, but it's just not suited for what we need out of high performance blockchains that are worth, at this point, trillions of dollars. So what do we do instead? We start from first principles. We go to the lowest layer in the networking stack, the OSI layer 1, 2, and 3, and we build a new internet from the ground up from first principles, built for performance, built for prioritization, built for optimization. And this system, because of how low level it's built, it's not a Solana-specific network, it's not an Ethereum-specific network, it's not even a crypto-specific network. We can use this for all types of high-performance distributed systems, but we're starting with blockchain because it's an area where people are very clearly willing to pay for it. You see validators and network operators moving data centers for 10 basis points of additional MEV. We can give significantly more than that over private networks. So this is really the future of what we think most blockchain infrastructure will run on. Even if you keep the public internet failback as a very important component for long-term censorship resistance, we need to start being willing as an industry to exceed what's possible on the public internet. And each network will have their own journey and approach to this. Ethereum decided long ago that they didn't want to get faster than a DSL connection, that it should be very cheap and you should be able to run Ethereum node on a shoebox. The L2s took a very different approach to this, but the end result is still something that's much faster, but it's still very slow compared to the public internet. And anyone that compared to like what Wall Street and TradFi is running on, and anyone that gets remotely close to this is giving up so much in terms of censorship resistance and decentralization. There's nothing against Hyperliquid. They built an incredible product, but the way they've accomplished that product is to put everything in pretty much one data center. And that's a very viable choice for the thing they're building. You can think of them as probably the world's most decentralized centralized exchange, which is an incredible accomplishment as a product. But if you try to break up the Hyperliquid validators and place them all over the world, performance would go down significantly because this is a very, very hard problem to solve. So what do? Dedicated fiber. Direct routing over private fiber, which is not run over capacity like the public internet, leads to significantly fewer hops, lower latency routing, and all of this really benefits blockchains and blockchain systems running on top of it. So we announced the project in December of last year. We launched in October of this year. So we have about this slide's a little old, we got about 37% of Solana operating on DoubleZero as of this morning. We have network contributions from the likes of Jump, Galaxy, RockawayX, staking facilities, Cherry servers, South Third Ventures, Distributed Global, there's a Terra Switch, Latitude, X Labs is coming and bringing in some connectivity down into Argentina. So we've got a huge amount of different systems and contributors running on this today. Some of the largest validators on Solana are running on DoubleZero as well. And there's about $28 billion of total connected value. This is the sum total of the validators of all assets that are operating on the network, similar to how TVL represents DeFi activity. So as we look forwards, the network's making about $4.6 million in annualized revenue if we take those numbers forward today. And this is just on from our MVP build out. This is the smallest component of what we think we can add to blockchains. And over time, we expect this to enable networks like Solana and other fast blockchains to push up towards 1 million transactions per second, which is the number that software package can actually handle. The problem is the public internet can't support running things anywhere near that fast. This is true for a huge number of networks out there, from Aptos to Sui to a lot of fast L2s, is that their limiting factor today really is the public internet. It's not the fundamental speed of the software clients that they've built. So this is all powered by the native token of the DoubleZero network, which is the 2Z token. And this is basically how the economic flows work in principle. Validators and other systems pay to operate on the DoubleZero network. Today, there's about a 10% burn on rewards paid in. That'll increase to about 50% over the next year. And the rest is used to reward the fiber contributors that are actually operating on this network. This is data from the first month of operation of the network. As I said, we went live in October 2nd. And so we're growing pretty quickly. At this point, there is approximately 70 different fiber links in the world connecting 30 different cities with 2.9 terabits per second of total capacity over that network. For context, the most performant Solana validators have about 10 gigabits per second of capacity. We're talking about 2.9 terabits per second in aggregate network performance. So where are we looking at now? We launched mainnet beta this year. We have new technologies like multicast coming onto the network before the end of the year, and we're adding new blockchain support in January, as well as rolling out a bunch of additional services over the next year, targeting mainnet launch in the spring. We're in mainnet beta now. What that means is there's certain components that are not as decentralized as we'd like to call the system in mainnet. But as I said, we've got 37% of Solana running on the network today. So I've got just a few seconds here, but I think multicast is a really important component to talk on because this is one of those technologies that you cannot run on the public internet. It's simply not supported by any ISP out there. So unicast is what everything uses to propagate data today. It's if your server has to send data to 2,000 other servers, you are sending that out 2,000 times, or you're handing it off to another server, which is sending it off to other servers. This is Turbine if you're familiar with Solana, or Raptorcast on Monad. Multicast is how it's done in the traditional world. That multicast is a hardware acceleration network for packet replication. And the way that this works is the validator sends the data twice, once for primary, once for backup, and it is automatically propagated to everywhere it needs to get to in the world in a very bandwidth efficient way. What this means is you can suddenly remove the lack of fairness in how stake is distributed. So in most networks, if you have more stake on your validator, you get data more quickly. If most networks today and most major staking providers run some sort of side network for distributing data around, so their RPCs are always up to date with their main validators as well. Multicast levels the playing field and makes this much faster. This is the same technology that Wall Street and traditional finance has been working on and running on for over 20 years, and we're bringing it to blockchain for the first time. I think that's about all the time we have for today. I will be back with my co-founder tomorrow to do a fireside chat. We'll have a bunch of questions. We've got a bunch of team members here in Argentina for the next few days, so would love to chat with anyone who's interested in learning more about the protocol. Thank you.